All right, this is for help on the Desmos activity and just some extra notes on 11C2, finding limits algebraically. Okay, so if I substitute 4 in to find this limit, I can see that I'm going to get 0 on top and 0 on the bottom, which is undefined. And that doesn't mean the limit doesn't exist. It means that we need to do some more math. So if I do some more math, I could factor the numerator into x plus 7 and x minus 4, and I see that I have a common factor of x minus 4 on top and on bottom, which divide to be 1. So I'm left with x plus 7. And if I were to graph the original function and this line, x plus 7, I would get the exact same line except for the point at 4. Where this function has a hole and this function does not. So these two functions are going to have the exact same limit as x approaches 4. They're just going to have different values at 4, where this one will have a hole and this one will have a value. So I can substitute 4 in. 4 plus 7 is 11, which means the limit as x approaches 4 of this whole function is just equal to 11. Okay, sorry, I was thinking I had the notes downloaded on this iPad. I do not. Okay, so the second question is the limit as x approaches 3 of x squared minus x minus 6 over x squared minus 11x plus 24. Once again, I'm going to factor the numerator into x minus 3 and x plus 2. And I'm going to factor the denominator, x minus 8 and x minus 3. And I can see that I have a common factor of x minus 3 on top and on bottom, which means there is a hole at this function at x equals 3. There's also a point of discontinuity here at x equals 8, because if I plug in 8, I'm going to get a 0 in the denominator, but there's not the same factor in the numerator, which means that at x equals 8, this function has a vertical asymptote. A hole at x equals 3 and a vertical asymptote at x equals 8. So I can just use the function x plus 2 over x minus 8 because this function and this function are identical except for at that hole at x equals 3. But the limit as x approaches 3 of these two functions is the same. So I'm going to find the limit as x approaches 3 of this function by substituting 3 in for x in the numerator and 3 in for x in the denominator. So the limit is equal to -1.